Okay, here we have a composition of functions. So this little circle means composition. What does it mean? Let me write here. So that means f takes g as input. So f takes a function as input. So let's say a. In a, so function f is defined as x squared plus 2x. But f takes g as input. So what is g? G is defined as 2x plus 1. Right? So we write it as f takes 2x plus 1 as input. And how is f defined? F says square the input, then plus 2 times the input. So now our input is 2x plus 1. So first we square the input. We have 2x plus 1 squared. Then plus 2 times input. So 2 times the input is 2x plus 1. So whenever we see a function, we think about input. What does a function do to the input? So the input can be anything, can be any expression, right? But usually we use f of x. The input is x, but x can be any expression, mathematical expression. So in this case, the input is 2x plus 1. So then we need to do a little bit of calculation. We see 2x plus 1 is a common factor. We'll factor out 2x plus 1. Then we have 2x plus 1, then plus 2. So 2x plus 1 plus 2, that's 2x plus 3. So we just multiply those two binomials, 2x plus 1 times 2x plus 3. 2x times 2x is 4x squared. Then plus the middle term. The middle term comes from 1 times 2x and 2x times 3. That's 7x. Then the third term is 1 times 3, which is the 3. So f composed with g. So we use this little circle to represent f composed with g, meaning f takes g as input. So in the end, we get a quadratic function. So let's see B. Also do f composed with g. That means f takes g of x as input. And let's write down g. G in this case is x minus 8. So that means f takes x minus 8 as input. How is f defined? F says square root the input. So we have square root of x minus 8. Square root of x minus 8. So f composed with g is f takes g as input. And g is defined as x minus 8. And the function, what function f does? Function f square root the input. Now let's say C. C is g composed with f. Then the g takes f as input. So we have g of f of x, which means g takes f in the input. What is f? F is negative x. So g of negative x. How is g defined? G says cube it, raise the input by 3. So the input is negative 3 now, negative x now. Raise by 3, then plus 5 times the input squared. So negative x squared. Simplify, negative x raised by cube, we get a negative x cubed. Negative x squared is positive, so I'll get it plus 5x squared. Okay, let's see. So G composed with F. G composed with F. So this notation means G takes f of x as input. Let me change my color. G takes f as input. What is f? F is negative x. So that means G takes negative x as input. How is G defined? G defined as raise the input by 3, then plus 5 times the input square. So the input is negative x, so raise negative x by 3, then do the input square, then multiply by 5. Simplify this, negative x raised by 3, that's negative x cubed. Negative x squared, which is positive x squared, so we get a plus 5x squared. D, also we do G composed with F. Again, G composed with F means G takes F as input. How is F defined? F defined as x squared. G takes x squared as input. What does G do to the input? Square the input, multiply by 3. So 3 times x squared the input, square. Then minus 4. Simplify a little bit. X squared, then square again. That's x raised by 4. So I have 3x raised by 4 minus 4. Okay, let's see what we done. G composed with F means G takes F as input. F is x squared. So that means G takes x squared as input. How is G defined? What does G do to the input? G square the input, multiply by 3, then subtract 4 from it. Now the input is x squared, so square x squared, multiply by 3, then subtract 4 from it. X squared, then square again, that's x raised by 4, multiply by 3, that's 3x raised by 4, then subtract 4. Okay, that's composition of two functions. Now let's see 13. So talking about inverse functions. Inverse functions, usually we use notation raised by f raised by negative 1. So f raised by negative 1. So if the inverse of f takes f of x as the input, we always get identity. And also equals f takes the inverse of f as input. Basically, so what does this say? This is saying the inverse of a function and the function itself undo each other. You see, f of x can be any function, but if we apply the inverse function to f, we just get identity. We just get x back. Okay. So now so we want to verify to see f and g are inverse functions. So what do? We do composition of functions. So first we do f takes g, f composed with g. So that means f takes g as input, and g is x divided by 2. And what f does to the input, multiply by 2. So multiply by 2 to the input, x divided by 2, or 2 times x divided by 2, that's x. So indeed, we did get identity. So that means f and g are inverse with each other. So the first one is yes. Okay. So this, if we compose two functions, we get an identity function. We get x, we get the input itself. That means identity. Identity function. So now let's see B. We do the same thing. We do f composed with g or g composed with f, either one. All right. So let's do f composed with g again. F composed with G, so F takes G as input, and G is defined as cubic root of X, cubic root of X minus 4. I'm gonna add the cubic root of X later, all right? I have to use pencil to do that. No, I'm typing. So what does F do to the input? F raised by 3, raise the input by 3. So I have a cubic root of X minus 4 raised by 3. Now let me put a cubic root, use pen. So G is defined as a cubic root of X. So I have index 3 here, minus 4. Cubic root of X, index 3 here, minus 4 raised by 2. So this, we don't get X, right? So this is not equal to X. If we expand this notation, we'll get 6 terms. So let's not do that. As long as we know this does not equal to X. So we know F and G not inverse to each other. So the second one is no, they're not inverse with each other. Now let's see C. C, we do the same. We do F composed with G, F composed with G. That means F takes G as input. What is G? G is the square root of X minus 7. And what does F do to the input? F square the input. I'm gonna add square root later on. And so square root of X minus 7 square. Then plus 7. Let's see, let me add the square root sign. So G is the square root of X minus 7. Square root of X minus 7. Yeah. So square root of X minus 7, that's just X minus 7. Square root cancel each other, right? That's the X minus 7 and plus 7. Oh, minus 7 plus 7. Yes, we did get identity function of X. So C, yes, F and G are inverse. Now let's see D. D will do the same. F take G as input. And then F take the G. How is G defined? 5x minus 11. I'm going to use, you know what? I'm going to need space. Later on, write to it. Use my pencil. Then equals to, so let me write. This is impossible to type. So F takes the G as input. G is 5x minus 11 divided by 3 minus x. Right. Now, what does F do to the input? It's a little bit troublesome. First, in the numerator, F multiply the input by 3, or the input is a big one. The input is 5x minus 11. 5x minus 11 divided by 3 minus x. Like 3x plus 11, then add 11 to it. Then the denominators, I'm looking at F, okay. So you see F is defined as the numerator, 3 times the input plus 11. So my input is 5x minus 11 divided by 3x minus x. So I do 3 times the input plus 11. Now the denominator, the input, add 5 to it. So the input is 5x minus 11 divided by 3 minus x. right? That's my input. Then plus 5. Okay, so I need to do a lot of calculation. I'm going to take the space from here. I'm going to go here, use this space. All right, let's calculate the numerator first. So 3 multiplied to the numerator. So multiply to the numerator, I get a 15x minus 3 times 11, that's minus 33. Okay. Then my denominator is a 3 minus x. I want to combine this with this 11. So that means I need to multiply by 1. And this 1 is a 3 minus x divides itself. That's how I make a common denominators, right? So I want to combine those two terms. I need a common denominator. The common denominator is a 3 minus x. So I multiply 11 with 1. And this 1 is a 3 minus x divides itself. So then I add to the numerator. Once I have a common factor, I add the numerators together. So I get 11 times 3. I get a positive 33. 11 times negative x, I get a negative 11x. So that's my numerator. So I simplify my numerator. So negative 33, positive 33 cancel to be 0. 15x minus 11x, I got 4x. So the numerator simplified to be 4x divided by 3 minus x. But that's only my numerator. So I'm going to keep it here for now. Now let's simplify the denominator. Denominator, I see 5. I need to combine 5 with 5x minus 11 divided by 3 minus x. I also need to multiply by this 1, right? I need a common denominator. So when I do that, the denominator, I have 3 minus x. The numerator, I have 5x minus 11 from the first term. And the second one, I have 5 times 3 minus x. So 5 times 3, I get 15. Then 5 times negative x, I get a minus 5x. Now I combine like terms. I have positive 5x, negative 5x, they cancel each other. Then I have negative 11 plus 15. That's 15 minus 11, which is 4. Which is 4 divided by 4 divided by 3 minus x. This is my denominator, right? So this is my denominator. So I have to use my numerator divided by my denominator. So dividing, I want to change to be multiplication. Then I take the inverse of my denominator, which means I flip the numerator and denominator. So now 4 becomes denominator, and the 3 minus x becomes numerator. So I see 3 minus x I have in the numerator, I have in the denominator. There's something divides itself, that becomes 1. I have 4x divided by 4, so 4 cancel with this 4. Oh, bingo, what I'm left with x, identity. So that means yes. So for D, yes, F and G are inverse with each other. Because when I compose those two functions, I get an x, which is an identity function.